Good morning, student. I, Bhagya MP, Assistant Professor, Department of Chemistry, Sai Vidya Institute of Technology. So, in this session, I am going to teach you electrolyte concentration cell. So, let us move on to the electrolyte concentration cell definitions and all. So, when you look into this diagram, so this consists of this whole diagram we call it as a cell. So, it consists of two electrodes. One is anode, other one is cathode. So, both anode and cathodes are made up of silver electrode, and both anode and cathodes are dipped in the same solution, which is that solution silver nitrate solution. But what about concentration of silver nitrate? It is different, it is not same. So that's why this whole thing or this whole cell we call it as a concentration cell. Then what is the definition of concentration cell? Concentration cell means it is also a galvanic cell which consists of two identical electrodes or two same electrodes which are in contact with the same electrolyte solution in different concentration. So that we call it as concentration cell. Then what is the construction of this cell? So how to explain this construction? So the cell consists of two electrodes. So both the electrodes are made up of silver metal, and both the electrodes are externally connected to the voltmeter. And electrolyte solutions are internally connected by salt bridge, and both the electrodes, that is anode and cathode, both are dipped in the same solution of different concentration. So that is the explanation of this cell. Then what is the cell representation? Cell representation, whenever we are going to write the cell representation for the cell, always first we have to write the anode cell representation followed by cathode. So here is the cell representation. Silver single vertical line that gives the boundary line, silver nitrate that is of concentration M1, double vertical line represents salt bridge, then silver nitrate M2, vertical line Ag. So this is the cell representation of this concentration cell. So now we'll move on to the reactions. So since this concentration cell consists of two electrodes, one is anode, other one is cathode. So anode means which reaction takes place? Oxidation. Oxidation means what? Loss of electrons. Cathode means reduction. Reduction means gain of electrons. So reaction means here we have to consider both anode and cathode reaction. So later we have to consider the overall reaction which takes place in the concentration cell. So first we'll consider anode reaction. Anode, since anode reaction means oxidation. So anode reaction is silver give rise to Ag plus. We have to mention the concentration of electrolyte solution, that is M1 plus one number of electron is liberated. At cathode, same again. There is a reduction takes place. So silver plus ions of M2 concentration accepts electron and give rise to silver. Then what is the overall reaction? Overall reaction is Ag plus M2 give rise to Ag plus M1. So this is the overall reaction. So for this reaction, we have to apply the Nernst equation. So that we call it as working. So Nernst equation for chemical reaction is E is equal to E naught plus 0.0591 divided by N into log of concentration of reactants by concentration of products. So in this concentration says E naught is always 0. Why? Because E naught is 0? Because both the electrodes, that is anode and cathode, both are made up of same metal. Because of using the same metal, automatically E naught get cancelled. And this E naught is calculated by the equation E cathode minus E anode. So as I said, since anode and cathodes are made up of same metal, E naught is equal to 0. So when we apply this E naught and the reactants and products of this net cell reaction to this Nernst equation, so what we are going to get is E is equal to 0 plus 0.0591 divided by N into log of M2. M2 means what here? In the net cell, this is a reactant. M2 concentration divided by M1 concentration. M1 is your product. So the same equation we can also write it as E is equal to 0.0591 divided by M into log of concentration of M2 divided by concentration of M1. So using this equation, final equation, we can able to calculate EMF of the concentration cell. So in this session, what we have learned? We have learned definition of concentration cell, construction, how it is being constructed, then cell representation, and what are the reaction takes place in the concentration cell. Along with that, we also learned working of the concentration cell. So this is about the concentration cell concept. Thank you.